This is the screencast for section 1.4, example 5. We're going to model, so word problems, with function composition. In the medical procedure known as angioplasty, doctors insert a catheter into a heart vein through a large peripheral vein and inflate a small spherical balloon on the tip of the catheter. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters per second. So here's your little balloon on the tip of a catheter, and that kind of gets expanded into the vein to open up blockage. So find the volume after t seconds. Well, the volume we'll call V. So let V equal volume after t seconds. So they've already defined what t is for us, and the volume is 44 cubic millimeters per second, so 44t. So far, so good. Now, volume here is a function of t, so I'm going to put v of t to represent that the input of this function is the variable t. Part B asks, when the volume is v, what is the radius? Now, that sounds like v and then the input would be r, but actually, if you read that carefully, when the volume is v, what is the radius? We are supposed to be outputting the radius, and volume will be our input. Well, I only know volume equals 4/3 pi r cubed in relation to volume and radius. So now I'm going to have to take that function and solve for r. So I'm going to divide both sides by 4/3 pi, which means I get 3v over 4 pi equals r cubed. Take the cube root of both sides. So now r is a function of volume, and that function is the cube root of 3v all over 4 pi. So far I have two functions. I have volume, whose input is time, and radius, whose input is volume. Now in part C, it says write an equation that gives the radius r as a function of time. Well, like I said before, I have radius as a function of volume, and I have volume as a function of time. So now what if I compose those? Radius as a function of volume as a function of time. So I'm going to take the radius function, cube root of 3v over 4 pi, and I'm going to compose the v of t function in there, 44t. Now I have a function of radius whose input is time. Part C specifically asks, what is the radius after 5 seconds? So I'm looking for the radius of the volume of specifically 5. So I want the cube root of 3 times 44 times 5 all over 4 pi. And I'm going to use my calculator to find that. If you go to math number 5, that little x means you can put in whatever root you want. I'm going to put in the root 3. Cube root of, now I want a fraction, so alpha y equals, I want numerator denominator. So in the numerator I have 3 times 44 times 5. In the denominator I have 4 pi. Hit enter. And that's what I get. The radius after 5 seconds is 3.74 millimeters long. So to recap, what I did here in example 5, I had a function of volume that related to time, and I had a function of radius that related to volume. I needed to get a function that related radius and time. The connecting variable there was volume. So I made a function of radius, of volume, of time, a composition. The now try problem is number 31. Weather balloons. Okay, so a high altitude spherical weather balloon expands as it rises due to the drop in atmospheric pressure. Suppose that the radius r increases at the rate of 0.03 inches per second and that r equals 48 inches at time t equals 0. Wow, that is a lot of information. Okay. Determine an equation that models the volume V of the balloon at time t and find the volume when t equals 300 seconds. So I am looking ultimately for V of t. I want the output to be volume, the input to be time. So looking back here, I don't have anything that relates volume to time, but I do know a relationship between volume and radius, so I can put V of r, and volume is 4/3 pi r cubed. And I also remember reading something about the radius's speed according to time. So suppose that the radius r increases at a rate of 0.03 inches per second. So the radius is 0.03 s. Now I have to keep reading here because it says at time 0 the radius was 48 inches. So I have to add 48 as my y-intercept there. So when I plug in 0 seconds, I still get 48 inches. Now this, 48 seconds should have been t, sorry. So now r of t and v of r exist. I have a way of connecting volume and time through the radius. So I'm going to compose that function. V of r of t. So 4/3 pi, not r cubed, but 0.03 t plus 48 cubed. The problem specifically wants me to find the volume when t equals 300 seconds. So V of 300 is going to be 4/3 pi times 0.03 times 300 plus 48 cubed. So using my calculator, 4/3 pi times parentheses 0.03 times 300 and then plus 48, that portion of it cubed, means that the volume when 300 seconds have passed is 775,734 cubic inches.